All right. Well, hello, everyone, and welcome back. So, I have with me here today two people that I've kind of been in communication with. I've known for a while now. Well, a while in internet time. It feels like a few months. I've known AJ longer than I have Mark, but anyway, I've invited these gentlemen here to talk about. I've seen a few of their debates on the topic of evolution versus creationism. And so I invited them both here to talk about this. And how we're going to frame it, at least initially, is we're going to have them present both positions. Mark will be representing the evolution position, and AJ will be representing the creationist position. I should note, however, this is not a genuine debate because everyone here accepts evolution as a legitimate scientific theory. This is more so for educational purposes, so to speak, to explore some of the common objections to evolution and to explore specifically with Mark and AJ what drew me, the reason why I wanted to have them on was because of how clearly they were able to present the evidence for evolution. So talk about both angles there. Unfortunately, however, especially in the United States, it's still, I think the last Gallup poll, I mentioned it in the description of this video, it's still upwards of 40% of the US population don't accept evolution as a valid scientific theory. So I think this is an important discussion. It's a discussion that you may or may not have with either some close friends or some people like at a dinner party or something, or of course, people on the internet. Not if you don't want to argue with people on the internet, I don't blame you. But anyway, so Mark, AJ, how about you all introduce yourselves and then we'll get started. I'll hand it over to you first, Mark.
Hello, how are you? I'm Mark Reid. It's a pleasure to be here. Thank you so much for having me on, Michael. And I want to really thank AJ for playing devil's advocate in this one, because I think that's definitely the harder thing to do. You know, arguing your own position is easy. Arguing one that you don't actually believe in, that is harder. Full props to AJ. I do debate. I occasionally run into people, have discussions. I do interviews with people occasionally. And it's fantastic to be here. So thank you so much, Michael, for having me on. And thank you for giving me your time today.
AJ?
Yeah. So I'm Atheist Junior. That's the name of my channel. I run a YouTube channel where I do live stream video reactions. I do debate reviews. I do some interviews also, and I have over 700,000 video views, and I'm almost to 7,000 subs, so it's healthy.
Nice. Well, again, thank you both for coming on. I have both of their channels linked in the description of this video. By all means, go check it out. They both have some fantastic stuff. And watch their debates as well, especially from even just from a communication standpoint. Both of these guys, just to brag on them a little bit, do an absolutely excellent job of clearly and simply communicating their ideas. Anyway, enough talk. Mark, would you like to start us off?
Fantastic. Thank you so much, Michael. I'm just going to share my screen because I do have a presentation. Actually, I'll get the presentation ready because I'm doing on this on thing. So what I've usually found is to focus on something that's really or the strongest evidence, right? So that's usually my go-to. The whole reason for this is because if your strongest evidence isn't very good, like you want to focus on what are your strengths. And so I'm going to present an argument that's the ERV argument, or endogenous retroviruses for evolution, because it's so strong that it really does absolutely put the last nail in the coffin for young Earth creationism. And it's good because you can really get in depth. So evolution's sort of a very complicated topic. it's very hard to go through all of the evidence in depth. So sometimes what I think is present one thing with a lot of depth so you can make it your primary case kind of thing. So that's what I will be doing in this one. So now I want to make it clear, I'm not a biologist or geneticist, and I can only speak to my understanding. And I like to couch that up front. I like to say, hey, I'm not in any way qualified to, teach this on any kind of level. This is my understanding of it. But what I encourage you to do is go out and find out, for yourself what evolution says, because there are people out there who can explain it a lot better than me and show it, and give you a deeper understanding than the overview, because it is very complicated. So, but first off, what's an endogenous retrovirus? Well, a retrovirus is one that transcripts its own DNA or copies its own DNA into another cell. So something like the AIDS virus, or HIV rather, I should say, I beg your pardon. It copies its own DNA into your cell and then gets the cell to make copies of it. So it's using the cell to propagate itself. Now, there's a very specific structure to the ERV. It's got a GAG, a POL, and a ENV sections to them. So when we see this in DNA, we know what it is. There's only one structure that has that, and that is a retrovirus. When the cell enters, or the DNA enters, the viral DNA enters your DNA, it makes specific cuts on either side with an enzyme called integrase. Now, this process causes the genetic sequence to repeat on either side, and that's the LTR section, or long terminal repeats that you see here. And that's a very, very specific structure, and the only time we see that is with retroviruses, and that's very, very important. Now, that's retroviruses in general, but what does it mean to be endogenous? What's this endogenous thing? So endogenization happens when the DNA of the virus the DNA of the host is transcribed so the virus can be passed to other members of the species. So what happens is when it gets infected, when that's passed along to other members of the species, it's called horizontal transmission. So if you infect one animal and it passes it to, another of the same kind, that's horizontal. When it's passed downwards, it's vertical transmission. So endogenization only happens when the virus infects the germline, so that the sperm or the egg of the organism. And when that happens, it can become fixed in every single cell in the body. And then it can pass that fixed genetic sequence to every single member of the species going down. So that's when it sort of integrates into the species. And you'll notice these don't have the retroviral elements, but in this specific lineage, it's become fixed in the DNA of all of the descendants. And that's endogenization. This is basically about fixation. I'll try to go through this very, very fast. So this is basically showing how in fixation, the virus can be turned off or even become mutated to be beneficial to the organism. I'll go into that a little bit later, but I want to describe how different series of organisms branched off before or after the germline infection, when it infects the germ or the egg, had the retrovirus integrate into the DNA. If you take these three species of rabbit, two of them, A and B, have the same site or location in their DNA. That's how we can tell that it sort of happened after this branch off. And they do have the long terminal repeat in exactly the same place in their DNA, along with the ENV, POL, and GAG sections of the GAG sections of the virus I mentioned earlier, their structure. There might be slightly different mutations inside the viral DNA element that occurred, but when the two groups of rabbits speciated, one gained a benefit from the viral sequence, while in the other species that branched off, it may be inactive, or even the virus may still be active. So with these mutations, we can tell where the mutation happened. So if species B has a mutation in its viral sequence and species A doesn't, we can tell where they branched off. So of course, species C doesn't have the viral sequence at all. So what we can tell is that the virus infected the germline after that species branched off. So it must have been up here. Okay. So this is a breakdown of a species tree where we have 2 ERVs and showing how we can tell when speciation occurs. So what I was talking about earlier. We have 4 species of animals here. If ERV1 is present in species A, B, and C, but not O, and O, it just means the out group. It just means the one that isn't part of that. We compare. We know that the out group slid off before ERV1 infected the germline of the other species. If ERV2 is present, if ERV2 is present in just A and B, we know that these 2 species must have split off from C before ERV2 infected the germline. And that's there. The bottom graphic is showing how retroviruses themselves can mutate and change over time. Now, don't forget, mutations, sort of like substitutions, deletions, insertions, they can occur anywhere in the cell, including in the viral elements. So there's nothing that says that once a viral element is inserted, it has to remain the same sequence. And that's just tracking a few of the clades or groupings of retroviral mutations, and they're the ones that we're tracking at the moment. Not all of them, just a few of them. And I'm just sort of trying to show how not only do these cladistic sort of phylogenetic trees exist for other organisms, they also exist for the viruses themselves. And this is how we track when lineages of organisms split off from one another. And keep in mind that these trees, or at least the ones for normal organisms, they existed before endogenous retroviruses were even found. We didn't even know about retroviruses before when we did the trees based upon things like anatomy and embryology and things like that. ERV slotted beautifully into our understanding of genetic theory. It slotted in perfectly, and it backs up all the evidence we have completely. A good question is, if evolutionary theory is wrong, why do ERV mutations and ERV markers in organisms point to exactly the same conclusion made sort of 150 years previously? All of these lines of evidence converge at the same answer. So let's focus on endogenous retroviruses in our nearest neighbor, primates. Now, all of this looks confusing. It is confusing. I totally get it. This is the thing that we don't see when we see the creationist presented. I don't understand any of it. Well, I mean, I understand basic little bits, but not at any great details, because I don't have a degree in genetics. The reason why we use simplified graphs is because it gets very, very complicated. And this isn't a simplified graph. This is what a geneticist would be looking at. I just want to mention that people like Kent Hovind and all of these people will jump on the things like the next slide and sort of say, hey, look, you believe this, it looks, this simplified thing. But that's just for people without degrees. What we are showing people is not what the people with the degrees will be looking at. They will be looking at stuff like this. So this is the simplified thing that we say. Oh, this is what the evolutionists believe. Well, no, they believe in that, not this. It's a basic breakdown of how we track ERVs and how we know when they split off. Just like the basic comparative of organisms, we can group them in. Just like in the basic comparison to organisms, we can find ERVs that separate primates into these groups using exactly the same logic. Now, apparently, keep in mind there's like 8,000 separate ERVs in mammal alone, and 8% of our DNA is made up of retroviral fragments, some of which have mutated or most of which have mutated to be inactive or even beneficial. So there's a massive list of retroviral segment information that we can sort of untangle over time. And it's very, very difficult to do so, very, very complicated. But we can track where not only which ERV each species has, but what mutations we can track through them as well. And that's how we know where they've split off from one another. A good example of this is the HERV-SL, which is human ERV. Basically, that same ERV is also found in reptiles, fish, and rodents. It's all found in all of these as well as your human. But if you look sort of further in the timeline, there's stuff like HML2, this ERV. That one is only present in humans and not even present in any of the other apes. But the question is, if we don't have a common ancestor, how did these ERVs get there? Because viruses attack in a random point in your genetic sequence. So the chances of individually humans, reptiles, fish, rodents, all being attacked by the same ERV, the same genetic sequence, in the same location of the cell is impossible. It is virtually impossible. So the question is, how did they get there? And the best explanation and the strongest explanation is an ancestor was infected and then it was passed down. So this is the retroviral sequence for the placental mammals. This allows mammals to fuse yolk sacs to form a placenta. All of the animals shown are mammals. We have some difference in the ERV elements in their DNA. We know that humans and mice are placental. However, marsupials have a different sequence and they use a different trick with their pouches. This is the SIRH family, and what's interesting to note that this family of ERVs is not present in monotremes, so platypus and echidnas. That is completely missing, which tells us that the SIRH, which is responsible or not responsible for, but contributes to the evolution of the placenta, it branched off after the monotremes diverged from the rest of the mammals. Because don't forget, platypus and echidna are still mammals. And that allowed us to evolve the placenta. So I'd just like to mention the fields that evolution has been used in practice. Not a lot's been said about this subject. Genetics companies hire graduates with deep understanding of evolutionary theory. It's been used to understand how organisms change. The phylogenetic tree has been around for 150 years, since 1866. We didn't even know about DNA at the time. Later, we discovered DNA. We found that the DNA lined up exactly as the tree predicted. Then ERVs were actually first discovered in 1980. And the way they explain the nested hierarchy of the phylogenetic tree is perfect. And there is no other way to explain how those viral elements got into exactly the same place in every single grouped organism, and why when you get closer on the phylogenetic tree, the more ERV sequences they will share. And as you get further away, the less they will share. And why they appear to be changing depending on the species that they are in. The whole theory of evolution with its mutation explains it perfectly. Unfortunately, creationism does not. Thank you.
All right. Well, AJ, would you like to go now?
Sure. So, Mark, I assume that was a good presentation. I wouldn't know because I wasn't listening, but it doesn't matter because nobody knows what an ERV is. Okay, so the majority of I'm going to talk about America because that's the only country that matters. But the majority of Americans don't know what ERVs are. Michael, do you know what an ERV is? Can you explain it? No. See, the majority of people in this StreamYard call don't know what an ERV is, just like the majority of people in this call are bald. So can you share my screen?
Absolutely.
So evolutionists like Mark, they aren't willing to accept the idea that there might be alternative explanations for why we find ERVs in the places that we do. Now, you might call this God of the gaps, but nothing about evolution has been verified with DNA. Okay, so this is one of the lies in the textbook that Mark is continuing to talk about, and it's not true that there's that ERVs are harmful, because we've found functions for them. Okay. DNA chromosomes are the most complex molecules in the universe. Okay. So just because DNA is small doesn't mean it's simple. Okay. The average human has over 50 trillion cells. That's a lot. That's a big number. You think these happened by chance, Mark? Shame on you. Shame on you. So I would like an evolutionist like Mark to tell me why the only reason an ERV exists in the genome is to prove common ancestry. So these could actually be proof of common designer. Did you think of that? No, you didn't. Okay, shame on you, Mark. And no, Mark can't provide a naturalistic selective mechanism for how ERVs jump in DNA from generation to generation. Are these movements random? Well, if they are, how can we know they're random? We're missing the big picture of the molecular puzzle here. Shame on you, Mark. Okay, that's the end of my opening.
Okay.
But a shame flying around there, AJ. I feel like you should have the bell. Shame, shame. Sorry, go ahead, Michael. I'm sorry. Yeah.
No, I was just going to say I do want to add a little bit to that, and I do also want to ask y'all some questions about the person who I believe AJ was channeling. But let's see. Let me add a little to AJ's presentation, if you don't mind, and then I want to get both of y'all's response to it. So, I've seen now. You all have interacted with some very different people than I have online, obviously. Sure. There are different, and I don't mean this to sound disrespectful to anybody, but there are different. All creationists are not on the same playing field. I'll put it that way.
This is true.
So someone like Kent Hovind, in my mind, doesn't belong. Well, I don't know if I should say doesn't belong. It's not on the same level as a Michael Behe. Right. So I do want to come back to who I think you were channeling your inner Hovind there. Am I right about that, AJ?
Well, yeah, but the arguments and the sources, if you want to call them that Hovind uses, is just, I mean, all creationists use a lot of the same arguments. So if you're citing one, like he got his whole shtick from I forget the guy's name. Basically, like Dwayne Gish and a little bit of Institute for Creation Research, and Walt Brown is the big one. I mean, he basically stole the name of Walt Brown's organization because his was just called Creation Science. And he did the whole hydroplate theory, which is Hovind's whole flood theory. So he repackaged a lot of those same arguments and just put them on DVDs and is selling them as his own intellectual property. That's what he calls it. Oh, and I have to mention this, is that in one of his latest videos, his new product that he's offering is a tablet that has his slides and his seminar videos on them for $400.
A tablet? Why don't you just get
I don't
files?
know. I know, that's what I thought. Like,
okay, so he doesn't understand evolution and doesn't understand copying files either. Doesn't understand computers either. Well,
unless it's like an iPad.
Here's the thing, right? And I get what you're saying, that somebody like Michael Behe is going to have a way better understanding of sort of, you know, the biomechanics of the cells and things like that. I totally get that. Now, the problem is that if you ask most, like, and this is my experience of Christians online, if you ask most Christians online, sort of, have they heard of Michael Behe? They haven't. And if they've heard of Kent Hovind, they have. And it's a sort of, you know, so Behe, while I totally sort of academically, he's a much larger figure, the real world is an academia. And I think we can all agree on that. And, you know, Kent Hovind's YouTube channel has like 200 and something thousand subscribers kind of thing. So while I agree not all creationists are created equal, that the same is true for their reach as well. And some of these people have a massive reach, even though their ideas are terrible. And I think that is part of the reason why we have the problem with a lack of understanding of these topics.
Yeah. So let me make this artificial division. Just bear with me for a little bit. So let's put Behe. Always pronounce his name. Behe.
Yeah, sorry, Behe. Yeah.
Again, Michael, you have an open invitation to come on my YouTube channel anytime you like. So yeah, let's kind of divide it up here, because I watched both of your debates with Hovind, and I do want to ask you both of you some related questions to that. But let me get your response to. I think we could more accurately call this sort of intelligent design rather than creationism, or at least within the. We can come back to that distinction if you want to, but.
Well, I'd just like to add, sorry, Michael, just that 40% of people thinking in intelligent design is horrifying. Like, that is absolutely horrifying for a start. Secondly, many Christians don't believe in young Earth creationism, which is what we're specifically talking about here. So, I just want to mention that.
Yeah, no, you're absolutely right. And that was from a 2019 Gallup poll, by the way. That was the most recent one I could find. So let me lay out Behe's argument. And Behe's argument, in a nutshell, goes back to William Paley's argument, early 19th century. This was prior to Darwin, and it's one of the big things that Darwin was responded to. And that is Paley's watchmaker analogy. The gist of it is that there are things in creation that are so complex that the intuitive assumption about those things is that they were put there by a creator. So Paley's watchmaker analogy is, suppose you're walking along the beach, you find a watch. A more contemporary example would be you're walking along the beach and find a laptop. And you're having a conversation with somebody, and they ask, how did this get here? It would be absurd for you. The absurd response would be for you to say, like, it appeared here over time.
Right.
Paley says that the same thing. Paley takes that and says that parts of the human body are analogous to the watch. For Paley, it was the eye. For Behe, it seems to be the cell. But it's the same. The gist of the argument's the same. And I want to read a really brief quote here from Behe and then get y'all's response. I'll shut up after this. But this is from a lecture that Behe gave early 2000s when he was promoting his book. He says that the cell is perhaps the most sophisticated piece of machinery that exists anywhere in the universe. When I say machinery, I mean it literally. The cell is chocked full of molecular machines, little trucks and buses that go from one place to another in the cell, little signposts, yada, yada, yada. Why is this a problem for Darwin's theory? Well, it turns out that Darwin knew that his theory had to be a gradual one. That is, Darwinian evolution had to work like numerous successive slight modifications of existing materials in the cell, one of which might give a slight advantage to its bearer and proceed slowly to improve the organism over time. And this is what Behe calls irreducible complexity. That there are aspects of the cell that are inexplicable via natural selection. And that because there are aspects of the cell that we can't explain, that this leads credence to the idea of an intelligent designer or creationism, however you want to phrase that. So let me get y'all's responses to that.
Well, you go first, AJ. I just want to look up something for 1 second.
Well, it's exactly like I said. There's so many cells in the human body, 50 trillion. That's a really big number. And Mark can't explain this complexity. Okay, shame on him for not being able to explain this. So DNA, not just a cell, but like my fellow scientist, Michael Behe, Dr. Behe, PhD, said, there's molecular machines within the cell. A machine is something that is designed. Okay, so Mark has to explain that, and he can't. He's failed, and that's why I won the debate, and I'm declaring victory, and I'll just leave it there.
Yeah, I can't find it. I'll have to go by memory, but that's not a problem. Okay, so basically, so this idea about intuition, we look at things intuitively. You mentioned it earlier, Michael, that intuitively it looks designed. Intuition is a terrible way to rely on for truth. Basically, you can look at a darkened alley and go, intuitively it looks dangerous. Is it dangerous? It may very well not be. It doesn't, intuition, while it's useful, it doesn't actually get you, it's not a clear marker of whether something is true or not. Now, the watchmaker analogy is interesting, mostly in the way that it fails. It's because that watch that you see on the thing, or the computer tablet, or whatever you're talking about, you know, on the computer tablet with Hovind's, you know, stuff on it that you see lying on the beach, is that isn't the only designed thing there. It's from an internal critique of the creationist position. It's actually a designed thing sitting on a millions of designed things, with a designed thing looking at it, with everything being designed. So why does that jump out at you as designed when none of the grains of sand, which were also designed, they don't jump out at you as designed as well? Because they were according to that model, as well as the trees in the background, as well as the ocean beside it, as well as everything around you. So that sort of raises the question, well, what is natural if everything was designed? And how are you making the comparison between the designed tablet and the designed grains of sand? It basically, you're saying that, hey, sometimes things that are designed are complex and sometimes they're simple. I think that this specific thing, and Matt Delahunty uses a good example as a beaver dam. It's been designed by the beavers, but it's almost impossible to tell the difference between a beaver dam and just a blockage of wood that's accumulated naturally through, you know, different processes. And sort of this idea that it's machinery, I think that has a load of connotations with it. So machinery, I think at a base level, we can sort of just describe things that do things for us, or autonomous processes. And yeah, I mean, if that's your definition of machinery, sure, but that doesn't necessarily mean that it's designed. It's interesting, and the thing that I was looking for, there was a theory I ran into that was sort of, or sort of a description of how things evolve over time. It's called the tabletop explanation, that basically what happens is that you have things that are necessary for that table kind of thing. So it has 3 legs initially, right? So it has 3 legs, and that's essential for it to being made. But then you take away one of the legs and it's still there. And you can sort of say, hey, it couldn't have formed because it needed the third leg to be formed. That's true to be formed, but that doesn't mean it needs that now. Sometimes that what a cell has can be taken away, and it doesn't actually affect the performance of it now. The main intelligent design thing I remember from Behe was the bacterial flagellum that he brought up in the Kitzmiller versus Dover trial, which was that the flagellum, which is responsible for movement in this bacteria, it basically moves it along. He said it couldn't, how did the bacteria move? It didn't have that. Well, you can actually, the exact same mechanism and structure that it's using could be a pump kind of thing. So it used it for another purpose before this one. And we can explain how that organic pump sort of got formed on this bacteria. So it's not... the whole idea that something is irreducibly complex doesn't address the co-option of parts for different purposes. That the bacterial flagellum couldn't have just sprung from nowhere, but if it was a pump before it became a flagellum, that perfectly explains where it came from. So that's why irreducible complexity is sort of known as a pseudoscience and thrown out. And you mentioned the eye, which is interesting, because the eye we thought was irreducibly complex, or rather the creationists said, no, it had to have been fully formed. You can't break it down, but they did. So our understanding of these mechanisms, irreducible complexity seems to live in sort of a God of the gaps area, in wherever we don't understand the process to it being formed. And then when we do, and I'm thinking of a guy called Otangelo right here, I better not say his name too many times, he will appear. But he seems to just go from one thing to another of whatever we haven't explained. And whenever you explain that thing, like we explained the eye, it started off as just a pad, a light sensor that was flat and then sort of curled around into the eye over time. Like, I'm not saying in one organism, like over a long stretch of time. These as soon as we explain that one, they don't go, oh, well, irreducible complexity must be wrong, let's move on. No, they just find something else. And as soon as we solve I think the one going around at the moment is do you remember, AJ, what's going around at the moment? The cell structure or something? I can't remember. Zinc fingers, maybe?
Yeah,
yeah, so as soon as we'll explain that one, and we probably will, they won't say, hey, we might be wrong about... they'll just find another thing to say, well, that's irreducibly complex, and, sort of ad nauseum. Sorry, I've been talking for ages. I do apologize. I'll leave it there.
Yeah, I'm going to have you share my screen again. So as for the watch or the tablet on the beach, so it's logical for a creator, whatever creator it is, to create rocks that can be broken down into sand, or to create sand. Or it's logical for a human being to take that sand and melt it down to create a CPU for a computer. It's not logical for the sand to make itself, Mark. And the flagellum on the bacteria, it's like a complex motor. Motors are in machines, and as we established, machines are designed. So you have all these things, all these big words that I can't pronounce, like this one, and the hair from a bacteria rotates up to 100,000 RPM. Again, that's a high number. Okay, and the higher the number, the more designed it is. So this motor is so tiny that 8 million of them would fit in the cross section of an average human hair. So that's very small, Mark. Very small. As things get smaller, the fluid they move in feels thicker to them. That was weird. That was weird. Really written. The bacteria swimming through water is like a person swimming through peanut butter. I would know. I've done it. Okay. A hair from a bacteria rotates up to 100,000 RPM. A big number. Okay. A big number. I rest my case.
Yeah, and this is the exact argument used in the Kitzmiller versus Dover trial, and that structure actually fits with a pump as well. I can't remember the name of it. It's a yeah. So what we think is that flagellum evolved from something else, and something we can sort of see. I'm trying to find the I did have a picture of this, but I can't find it. It's basically exactly the same structure, so it didn't just get designed from scratch. It's the co-option of function from another structure that's very similar.
Well, Michael, this is what the evolutionists always say, that it evolved from something else. And then you ask them to explain, well, what did this evolve from? And they'll just say, well, we don't know yet. We need more money. We need a bit more government grants. Okay, this is why we should give all the government grants to me instead of giving them to scientists, because I think, that money would be better spent so I can get, more ATVs and more tractors.
more gift shops for your dino
more,
man. Yeah,
more tablets.
Yeah. Well, this was actually looked at in a court of law, and Behe sort of said that there was no peer-reviewed published articles for intelligent design. He actually admitted that on the stand. There is nothing scientific about intelligent design. It is a pseudoscience. There's nothing in it that sort of explains anything. Intelligent design is really couched in religious belief. There's no explanation to how these bacteria were designed or anything like it. However, evolution does have an explanation to how structures can become increasingly complex over time in these organisms, and we have a lot of evidence to back that up. But I would like to talk about some of the things that AJ said in his opening, which was interesting. It's weird that he sort of said that ERVs are like sort of, they have function, and sort of what we talk about is the co-option of function, that things that are detrimental can mutate and become beneficial for them. But the interesting thing is some of these ERVs, they're inert. They don't do anything at all. They've basically been switched off, or you can reactivate them by putting in sort of a genetic sequence and they become active again. So why would a god put in an ERV that has a chance of becoming active again?
Well, it's because we live in a fallen world, Mark. There's people like you.
Fallen world. Oh, I should have known it was my fault.
Shame on you.
Must be. Shame on me. Yes, shame on me. And the whole thing that's saying it's chance is a bit weird, because things don't happen by chance when it comes to evolution. The mutations, you may say, hey, it's chance, or the ERVs might at chance hit a random location, but the whole process is deterministic. Basically, the animals with the beneficial traits will survive. So the ones that get ERVs and they stay detrimental will be at a disadvantage, while the ones that the ERV mutates and becomes beneficial will continue onwards. So it's not actually chance at all that establishes why one organism has beneficial ERVs and why one organism, and we don't see organisms that don't. It's because the ones where the retrovirus was incredibly detrimental, they died. You do understand that, right? They died.
Right. So the ones that get this beneficial mutation, what happens to all the other ones? They have to die, or else this one with the beneficial one gets swept back into the population. Yeah, I understand completely, Mark, better than you do. Shame on you.
Shame on you. They died. Yeah. So it's like saying, okay, and I love this analogy because it explains it really simply. If you've got a number of dice, okay, and I'm a huge role-playing fan, so
I don't gamble. It's a sin.
Well, but you do have dice. You play board games, so shut up, Hovind. Like if you roll dice, if you, yeah. I'm sorry, moderator. I'm getting frustrated with the Hovind. If you roll dice and then you take out the lowest ones, yes, the dice rolls are random. They show random numbers, but it isn't chance that you get a higher number, right? So while you say, hey, but the dice are just random, like mutations are random, what they roll is random. But if you're taking out all of the lowest numbers, so you've only got 5 dice left, it's not a surprise when, they are all high numbers. That's not chance. That's deterministic.
Well, why is it that there are gaps in the fossil record? Shouldn't we know all of them fossils if we know what animals evolved?
I think you're a fossil. There's no gaps in the fossil record. There's certain organisms where we say, hey, this is what we think we should find. And the interesting thing is when we say, hey, there should be something there with these properties that isn't, what we do is we find it, like Archaeopteryx, where we said, hey, there has to be a bird with teeth somewhere because we know that birds turned into dinosaurs. Dinosaurs turned into birds. So there's got to be a bird with teeth. So the dinosaur turned into a bird. And we found that, but that was a prediction before we found it. I think Darwin made that, the bird with teeth, which was Archaeopteryx. Another one was Tiktaalik. We sort of said, hey, because we know that we started as fish and then went up onto land, there has to be a fish that walks around on land or has sort of feet for fins. And then we found that exactly at the fossil record layer that we expected to find it and looked exactly as we predicted. So the whole idea that there's gaps, because every organism is changing over time, you can always find a gap. You can always say, oh, well, there's the missing link between X and Y. Oh, but what about between them? And then what about between those two? And what about between those two? And because fossils are rare, we can't possibly find every single organism that's ever existed. That's completely ridiculous. But because everything's always changing, you can always find a gap between two organisms.
Okay, so you said that it's not true that when I said that they found a function for all these ERVs, or if it is true that there is harmful viruses that were inserted into the DNA, or that there is junk DNA, why would this be preserved for millions or billions of years if it didn't have a function or if it had a harmful function?
Because it may be that it doesn't have enough of a harmful function to really impact on the organism. Things generally find equilibrium. And if it's just junk DNA, I dislike that term because it sort of suggests that it has no function whatsoever, where it may indeed have a function if it's co-opted, especially ERVs, where if they are co-opted by the host, they can prevent the same type of virus from entering the body. So why have they been preserved? They're not preserved. They're changed. Preserved seems to suggest that their genetic structure is the same. They're not. That they have been mutated over time exactly as evolution says they should be.
Can you give me an example of increasing genetic complexity?
Increasing genetic complexity. I don't know what you mean by that. What do you mean by that?
And just an example of any time that there's been an increase in genetic information in the genome.
An increase in genetic information in the genome. Well, I guess one good example is nyelinase, nyelinase, which is a enzyme that a bacteria produced because it adapted to living in the waste output of a nylon factory. It actually now produces this enzyme which can break down nylon, and all of this happened completely natural. Well, when I say naturally, obviously the nylon output wasn't natural, but we didn't genetically modify these bacteria. They just developed that on their own as a response to their habitat being destroyed by nylon waste. And nylon isn't even a sort of natural product. It's completely man-made. But these bacteria evolved to be able to take the nylon waste apart and feed upon it. In the Lenski labs, they've done essentially the same thing with citric acid. The bacteria there, the E. coli, I think it is from memory, they introduced a citric acid environment, and the bacteria evolved to be able to eat the citric acid without having any problems with their function, eating other things as well. So that's an increase in genetic information.
Well, in that case, with the nylon, those bacteria, there's still a bacteria, and it's still E. coli. It didn't grow a wing, Mark.
Yeah, that's exactly what evolution says. It says that the law of phylogeny says that you will be the same thing that you were before. So we are always going to be mammals. We are always going to be vertebrates. We are always going to be the clades that we have fitted into previously. So what we describe now, like for lizards, for instance, is non-avian dinosaurs, essentially. Or non-avian reptiles, I should say, rather. Just as birds are still a form of reptile because they were dinosaurs. So just because you change doesn't mean you get outside of the clades that you fitted into previously. So we're still eukaryotes. That's still what we are. It doesn't mean you're a single-celled eukaryote, but you're still a eukaryote.
So we're eukaryotes. A eukaryote is a cell with a membrane around its nucleus, but the cell is extremely complex, Mark. You have 50 trillion cells in your body. That is a large number. I don't know how many times I have to say it. It's a big number.
It is a big number, yeah. Well, I mean, it's not really big compared to some other numbers.
Well, why isn't it 49 trillion?
Why isn't it 49 trillion? Well, I must admit, I don't know the reason why it's not 49 trillion. Yeah, so just because something's a big number doesn't mean it's in any way significant to design. A beach can have trillions and trillions of grains of sand, doesn't mean it's designed. It's got nothing to do with it. Complexity doesn't even suggest design. In fact, when you're designing something, complexity is not what you're after. The whole idea of design is that you want to keep it as simple and elegant as possible. The problem is that organisms have these very weird and unnecessarily complex things, like the laryngeal nerve, which goes from your neck down around your heart's aorta and then back up to cross a gap about this big. There's no reason for that unless we had that same structure as fish, where you don't have a neck and it elongated to follow the same loop. And it gets really a problem in things like giraffes, where it goes from all the way down its neck, loops around the aorta and back up. I think that's the recurrent laryngeal nerve. It's not that complexity isn't present in design. It's that unnecessary complexity is not present in good design. And I expect a omnipotent creator of the universe to have the best designs, and organisms are not the best designs. Sometimes they're terrible designs. So explain that.
Well, at the end of the mating season, the male duck's penis falls off. Now, how did that evolve, Mark?
Well, it may be efficiency. It may be something to do with a selection process that maybe a female duck is attracted to a detachable penis. Did you ever think that, AJ? Did you ever think of that?
I don't think so, because male ducks are rapists. So I don't think the female duck is very attracted to them.
Well, I mean, I don't know what a female duck is. Have you talked to many ducks recently?
No, I may be a doctor, but I'm not Dr. Doolittle.
Where did you get your degree?
I got it from a prestigious university.
You meant a shed in a car park or something?
It's not a shed. It's a double wide trailer.
Yeah, well,
There's a difference.
Oh, okay.
It has
okay.
wheels.
Let me build off, ask some related questions to it. By the way, and I think I said this on one of your videos before, AJ. Hats off to anybody who pursues a PhD. Like I said about creationist, though not all PhDs are created equal.
Well, you want them to be accredited. And look, Hovind's PhD dissertation, if you could charitably call it that, was basically just a transcript from one of his speeches. So I acknowledge that people work hard for PhDs. It's just if you're just going to hand in the transcript of a talk you've done, I'm really sorry, but I refuse to acknowledge that as a PhD work.
I can't get over. I think it starts off with "Hello, my name is Kent Hovind."
That's because it's a transcription of one of his speeches. You know, like
like I just can't imagine submitting that to any to any school I've ever gone to. Like,
right?
It was approved by the president of the school, so.
I think that sort of an uncredited dissertation like Hovind's, that the people, it cheapens the whole idea of a PhD. That level of knowledge required. If you can just hand in a transcript of a speech that you did and get a PhD, it cheapens everything that academia is working towards. So I'm very stringent. I agree with you. I respect anyone that gets a PhD. He doesn't have a PhD as far as I'm concerned. I'm sorry.
So let me ask y'all some questions, common objections that I heard when I listened to both of your debates with Hovind specifically. So what stood out to me the most is there was this, I don't even know what to call it. It was so we have the biological theory of evolution, but there was this insistence that we had to start like at the beginning, and that evolution incorporated more than just biology. Like when Hovind talks about evolution, he's talking not just about biology, he's talking about cosmology, he's talking about lots of different aspects of chemistry. He's talking about, he starts with like the origin of the universe. So, and I think both of you responded to that in different ways, but let's start there. Let's start with this, and I don't think that's unique to him. I think most people have a lot of confusion about what evolution actually is and what the theory of evolution actually refers to. So let's start with that. When we talk about evolution and when we talk about the evolution of species, what exactly are we referring to, and how would you respond to this sort of understanding that when we talk about evolution, we have to go back to talk about like the origins of the universe or cellular, galaxy formations and stuff like that.
Right. So because he's not wrong that we sometimes refer to it as stellar evolution, like the evolution of how stars form. I think that anybody who is even slightly charitable or understanding, like colloquial, when you say evolution, you're talking about the theory of evolution explaining the diversity of species. It really is just a talking point or a dog whistle or some kind of sort of let's try and make the person that believes in evolution mad by saying, hey, you have to explain all of it, kind of thing. They know that we're talking about diversity of species. It's why when I debate Hovind, or not that I will anymore, but when I did, I always insisted on biological evolution, because that technically is the evolution that we're talking about. However, that doesn't stop him. He still talks about stellar evolution and things like that, which we know is different. These are bad faith interlocutors. They are people that are not working in the best way. The only thing you can really do is point out that evolution doesn't even explain the origin of life. It only explains the diversification of life, why we have such a diverse array of life. It's contrasted with the creationist explanation for the diversity of life. Because don't forget, in a debate, you're not expecting them to explain how God created the universe, right? You're only expecting to counter evolution, which is how did we get the diversity of life? And the creationist account is that it was designed with the complexity that it now has. So it is those two competing theories that we're talking about, or hypotheses, if you will, that we're talking about. That's the only way. I mean, if somebody wants to say that, hey, in order to explain evolution, you've got to explain everything that's ever happened, it's just a bad argument.
Yeah, I think that maybe we're a little bit at fault, because if you look at the title of this video, it says evolution versus creationism. So when you even agree to a debate with somebody like him, you're basically sort of opting into an argument which is our side is starting at, our Earth exists and there's biological life on Earth that is in its current form, versus creationism, which is about the creation of the universe and Earth and all the planets. But it's sort of a way for creationists to even the playing field, because I think part of it is that they know, and they probably wouldn't admit, but the fact that scientists have so much evidence for the theory of evolution, but they don't when it comes to abiogenesis. They still don't know how or what the origin of life was, or what happened to explain that. And it's really kind of just a gish gallop too. And that's the way that Kent Hovind does it. Is he says, well, you also have to explain the Big Bang Theory, and also I'm going to misrepresent the Big Bang Theory, so you have to detangle my lies about it, and planetary and stellar formation. I'm going to say that nobody's ever seen stars form, and just tack all this other stuff on it, just to extend the argument, so that you spend so much time defending your own position. That way that he doesn't have to defend his own position or actually get into what the actual debate is supposed to be about. It's just really him padding for time, I think.
Well, it's interesting that he won't debate, like I've challenged him on multiple occasions, evolution versus creationism, and he will not take up that debate ever. He only wants to debate evolution because he does not want to defend his own beliefs about where it came from. So he will not do sort of theological debates. He will not do philosophy debates. He only wants to do evolution and evolution alone. It's because then he doesn't have to put up any actual his own worldview doesn't have to be examined. He can then just say, hey, I'm examining yours. Flat earthers do it a bit as well. They sort of go, well, we're debating the globe Earth, and they will not agree to any debate that says, is the flat Earth real, for instance. They want to debate, is the globe Earth real? Because then the burden of proof is on the person making the claim that it is a globe, or making the claim that evolution is true, rather than having to defend, is creationism true?
Yeah, I mean, you said at the beginning that I had the harder job here, but I think it's been easy for me to. I've had to put you on the defensive, and I just, arguing from a creationist position is easy because I've basically just been bullshitting, but you've actually been trying to look stuff up.
Thanks, AJ. Cheers, buddy. No, it's fine. I really don't mind, but I don't know. I find it difficult to argue against for something that I don't believe in. I find it incredibly difficult.
I guess it's just because I've heard it so much.
Maybe too much, AJ. You ever thought about that? Like way too much. Like,
probably.
Yeah. Well, taking one for the team right there, AJ. Taking one for the team.
you made a good point, AJ, because I noticed this too. And Mark, you brought up flat Earth because this type of argument, this kind of category of argument or lines of objection, it's not an argument. It's really just trying to poke holes in what's being presented. You see this a lot in conspiratorial thinking, and I was actually just having a conversation with some students of mine about this. And this might explain, Mark, what you were saying about him only taking debates about evolution, because it seems like what happened in Mark, I think you had 3 debates with Hovind, right? And AJ, you've had 3. You've had quite a few.
I've had 2 debates against him. Mark's had 3, I think, at least.
Yeah. I did Noah's Ark and then 2 on evolution.
Oh, okay.
But I won't debate him anymore. It's I think that everything that I found out recently has been a bit much. I don't want to be associated with him.
Yeah, I'm happy to just help coach people who are going to debate him. I find that to be more fulfilling because I'm not interested in doing it myself. But the way I see it, if people are going to do it, then I would rather do that, and encourage them to do it in the right way if it's going to happen, which it seems like people are going to still do it, so.
Well, he's not bad to like sort of cut your teeth on as a new debater kind of thing, because he's not very good. He really isn't very good. He's got these arguments that what he's going to use, what he's going to say, especially if AJ helps you out and sort of says, hey, this is the stuff he's going to present to you, because we know what he's going to say. He only threw me a curveball once, and we had already planned for that between AJ and me. That's the thing. AJ said, hey, he's going to bring up this paper if you talk about ERVs. And I'm like, oh, okay. And so we knew exactly what he was going to do. He is so predictable that I think he's good if you are getting into debate, because you can sort of just plan for every eventuality.
Yeah, me and Mark, we did a debate prep before that debate, and we did a sort of mock debate like this where I was giving Hovind arguments. And a lot of the stuff I said, I think, came up in the debate. I know at least one of the papers that I knew just because I looked at the video he did about ERVs. He just used the same exact papers. So,
well, I think those papers were given to him by Donnie, because they're papers that Donnie uses, and that's standing for truth. I think his name is out there, but they're the same papers. So the second one I could easily look up because I have a list of the papers that Donnie uses for his ERV arguments. The funny thing is that the papers explain how the ERV elements were co-opted to become beneficial. So these papers I could actually use against him, and he did not like that at all. That I basically said, hey, let's read through. And the papers mention evolution several times, so his papers actually refute himself. So I don't think. Sorry?
He got mad.
Oh, yeah. Yeah, he did.
Yeah, because you brought up, you were talking about the papers that he brought up. And that he got all mad when you, he started saying that it was your idea to debate about ERVs, or that you brought it up when it was the actual topic of the debate, something like that. I don't know.
No, the topic was evolution. It's just that's what I brought up in my opening because it was such strong evidence. But he was saying that I was trying to change the topic.
Yeah,
and
that's what he said.
Yeah, that I was trying to change the topic when I was talking about the papers that he brought up.
Yeah.
I
remember that.
It's just so strange, and he was so mad. And it's sort of like, well, if you're going to use cite sources, make sure the sources agree with you, because someone's going to look them up and come back. I think that it's a problem that the sources completely contradicted what he was saying.
Well, I saw a video that Logic and Paulogia did where they were reacting to an old Hovind seminar. And one of the arguments that he brought up was the Sahara Desert shrinking or something like that. And one of the papers he mentioned, Logic was looking at it, and he looked farther down in the paper, and the paper uses, a deep time for its timeline, Like it's not it's talking about millions of years. I don't see how you can use a source like that if you're a creationist.
Well, it's cherry picking, and that's
Yeah.
essentially what we see. We see that they'll take a paper, take bits and pieces out of it, attach their own conclusions to those bits and pieces while ignoring the rest of the paper that contradicts them, and then sort of say, well, this paper supports me, and wave it around in the air like it supports them. I call this the Maddox methodology, because John Maddox uses it all the time. He will take a paper, take bits and pieces out of it, make his own conclusions, and then say, hey, the paper supports my conclusions. No, it doesn't. It doesn't support your conclusions at all. You've cherry-picked things out of that paper and then claims it supports you. Who else does that? Otangelo does that all the time. He will sort of point to a paper that completely disagrees with him and then say it supports him because, there's something in it that, well, he sees that he doesn't quite understand, but he sees it and says, well, that supports my conclusion. And I don't think that's right.
Yeah, Otangelo emails me trying to get me to buy his book. I'm like, no, I don't want to buy your book.
He wrote a book on what?
I don't know. I'd have to check.
I don't know. Apparently he's on the Shroud of Turin these days, which is just hilarious.
Yeah, that's one of them.
Yeah. Anyway, sorry, Michael, we're kind of rambling.
So good. Yeah, I brought that up to say that it seems like a common tactic here. And it's unfortunate because it's difficult to build positive arguments. But positive arguments are oftentimes what's required. So if we're arguing about evolution and we're arguing that evolution's true, as we just saw with what you did, Mark, you're providing evidence for the validity of evolution, showing how evolution as a scientific theory made claims that were later validated or later
Testable
explained.
predictions, yeah.
Testable predictions. It has a successful history that's been shown on numerous occasions to work. The issue is that the line of attack. Again, I'm referencing your Hovind, both of your debates with Kent. It's the opposite of that, which is to say, and I think y'all correctly identified it as gish galloping, that, or whataboutisms, like, well, what about this? Well, what about that? Well, what about this? But I have yet to listen to one of those debates where, and that's why I like Behe, is because Behe's actually putting forward an argument.
Right.
Behe's actually saying his arguments actually like play by the rules, so to speak. They play by the rules because he's saying like this is an example of irreducible complexity. Like he's putting forward actual evidence. But I haven't heard Hovind do anything like that. I could be mistaken because it's not like I listened to his entire catalog or anything. But yeah.
Right. So Hovind's basically his greatest hit is a logical fallacy called the argument from incredulity. So he basically will say, well, you believe that we evolved from a amoeba, or he even muddies the waters by saying you think we came from an amoeba, which sort of it's sort of conflating that we suddenly sprang from this amoeba rather than we evolved over, billions and billions and trillions of generations, or, it was so gradual going way back to a sort of primitive prokaryote kind of thing. So the whole thing, he just says, I don't believe this. I can't see how anyone could believe this. That's my argument. And that's all it is, just incredulity. Just, I can't believe this happened naturally, which isn't an argument. It's a logical fallacy for a reason. That doesn't mean the conclusion is wrong, but there's no reason to believe that God designed something because you're incredulous that it happened naturally.
Yeah. So the question, and I can use this to kind of close this out here. There's also this kind of very weird, almost like extreme form of like skeptical empiricism, where if I can't if I don't see it, or if it's not immediately available to my senses, then I reject that evidence that underlines a lot of these arguments.
Were you there, Michael? Were you there?
Yeah, exactly. Right. Like a very, very high bar of evidence and doubt towards any science or history that deals with past events. What would be both of your kind of go-to resources? Let's forget Hovind for a second. If somebody actually comes to you and is generally curious about just basic information about evolution, like clear, something that's tangible to them that they can kind of dig into. Let's assume that they don't have a lot of background information or knowledge about this. Kind of where would you direct them that would be easily accessible? I don't know. I don't really think about this example.
I would say no.
Yeah,
they're not religious.
Well, I mean, if they're not religious,
they're open-minded religious person, let's say.
Yeah, okay. So if they're a religious person or a Christian in particular, I'd probably direct them towards Biologos, because they're a group of Christians that believe in evolution, and they present really good evidence for the evolutionary process. Like, Christianity aside, and they can believe whatever they want. Their science is good. Like they do, why the Earth is geology and, all of the stuff from mainstream science. They couch it in, we believe in God, we have faith kind of thing. But this is the scientific facts kind of stuff, which, I respect that they're out there. They make no bones about their faith. I'm fine with that. But they are presenting the real science, which, that's fine. So I would like to direct people towards similar demographics, or, so Christians towards other Christians, simply for the fact that you don't have to believe in a young earth to be a Christian. You can still believe in a God, and that God started all of these processes. And what I've said many times is evolution doesn't debunk a God. Like, it doesn't make the God not exist. There's plenty of Christians that think that God designed the process to work like it does and then left it run kind of thing, like you would leave a computer program running kind of stuff. So trying to appeal to them and get through to them on their level is a really good idea, in my opinion.
Yeah, I would probably just say to watch Stated Clearly's videos.
Yeah, Stated Clearly does excellent videos. Yeah,
pretty much. His content is so concise and simple and well animated. It's easy to understand, and he's a really nice guy too. I had him on my channel, and we had an interesting conversation.
Yeah, they're very simply animated. Like, they really simplify stuff down. Because as I mentioned in my presentation, all of these, like, if you're talking about evolution, you're really talking about genetic sequencing and mutation, which is insanely complicated. Like, I would never, I do this presentation, I would never claim to understand exactly how. Like, I have a basic layperson who's done a little bit of research understanding of it. I can convey the ideas that have been simplified for me, but I can't explain how, sort of genetic, a mission of genetic sequences and how it works and what's happened. I just don't have that knowledge. The problem is that the people out there, they are that advanced. And we have this in science all the time. It's really hard to convey these ideas because their understanding is so advanced that it becomes difficult to communicate it with average people, and it's a problem. I know, sort of being in an IT sphere myself, it's sometimes impossible to communicate your understanding of how, say, for instance, the peer-to-peer networks within the internet work to somebody that doesn't understand the basic concepts of internet protocol kind of thing. Like, it's impossible. So it's a problem.
That's why you literally have to take over somebody's desktop sometimes.
Yeah, absolutely. Well, I mean, yeah, kind
that's
of.
why that function exists,
Sure. But if you're talking about sort of, say codons and how they, how endogenous retroviruses, invade another cell, it's incredibly difficult to talk about it. It really is, especially for somebody like a virologist whose understanding is so complex. They're going to use terms and words that I won't even understand it, and I've tried to look into it as much as I can. I am no expert, absolutely.
All right. Well, thank you, gentlemen, again for agreeing to come on here and talk about this topic. Before we leave, just very briefly, tell everybody where they can find you and a little bit about your channel, maybe some projects you're working on, anything you would like to share. AJ?
Sure. Well, my channel, I'm sure the links will be on this video, but I recently rebranded the name of my channel. It's now Atheist Junior, just to make it a little bit easier to search for it. And I'm, like I said, I'm getting close to 7K subs, which is pretty exciting. And next month, I'm going to be doing another collab with Emma Thorne. So
I
that's
love
going to be
those,
awesome.
yeah.
We're going to be looking at some videos by, I forgot the guy's name. The Daily Wire.
Hey?
The Daily Wire guy.
Ben Shapiro?
Not Ben Shapiro. The guy who made the movie What Is a Woman?
Oh, I can't remember his name, but I know who you're talking about.
That sounds delightful.
Yeah. Nice.
Matt Walsh. I don't know why I couldn't think of it. Yeah.
Walsh. Gotcha.
That guy gets an alarming number of views.
Yeah.
It's crazy.
Mm-hmm.
But yeah, we're going to be doing a video about him. I think it's been a great year for my channel. So I'm hoping to just keep the train rolling and do some collabs. Like I recently did a collab with a smaller channel, and I encouraged Mark to, put out more content and take his channel more seriously. And he's been growing really fast. So that's been cool to see. And, so I like doing that, so I plan to keep trying to reach out to other channels, big or small,
Yeah. Yeah, AJ, you've been incredibly kind and generous. And yeah, I reached out to you, respond, brought me on your channel. It was,
Yeah, I remember that.
Stuff. Yeah.
Yeah, AJ's been absolutely fantastic and supportive, and he's a fantastic guy. I really highly recommend a sub to AJ. His Hovind impressions and they are on point. Like they are so good. It's incredible. No, I love AJ. He's such a great guy, and behind the scenes, he's done so much to help me that he doesn't talk about it, doesn't mention it. He's been an absolute amazing person to help me out. And I'm really nobody. I've got 600 subs and a dog kind of thing. So I really appreciate it, AJ. I probably don't tell you that enough, mate. But I really do appreciate it. And I don't know. I kind of see pay it forward to go on other people's channels and help out. I know I'm more doing this for a lark than anything else. But AJ has been trying to tell me to take it more seriously. I've been trying to recruit my wife to do thumbnails and stuff, which is hilarious. Okay. So I've got coming up. I'm probably going to go on Rage to Reason's stream soon, Knock, and tomorrow, and talk about the dangers of sort of cults and these fringe religious groups that are doing harm. This came up because I did a stream on a group of 14 people sort of stood around and watched a girl die of insulin. They didn't give her insulin, and the families just stood around and watched her die essentially, and they thought that a God would bring her back to life or save her and heal her kind of thing. And this is incredibly dangerous, and it wasn't the first time it happened. It just is I'm all for religious freedom until things like this happen, and it's just horrifying to see. I've done debates on sort of demon possession, and people die in those as well, just unnecessarily, because they are suffering from mental illness or other ailments. Sort of combating stuff like this is I feel it's what I want to do. Sort of shining a light on these kind of dangerous practice. And it's not just religion, just even, some very, very extreme superstitions can get you into these problems as well. I mean, you were talking about conspiracy theories before. I'll point at sort of, sovereign citizen stuff and things can get you into a lot of trouble, and there's no reason for it. It's just this distorted beliefs that sort of about the world that are incredibly unhelpful. But as I said, I do debates. I love doing debates. My next one is on Standing for Truth's channel against, I think it's T-Rock, Age of the Earth, which should be fun. So I've got to look up or two on look up about sort of radiation decay and things like that, which will be fun. That should be a lot of fun.
Yeah, let me know if you want to do like some type of debate prep for that debate also, Mark. But I just wanted to point out, you said you had like 600 subs, just to put it in perspective. So you're familiar with the channel A Bit of Orange, I'm sure. And he created his channel in 2016, and he's sitting at 654 subs.
Yeah, but he's an absolute shocker. Like, seriously, we've looked at this guy's stuff before, and he is shockingly nasty and horrible. It's sort of a creationist that touts himself as your friend and friendly, and then he says like some of the most heinous stuff I've seen. It's really bad. Maybe he's a friend to white males who cis white males, basically, of the right sexuality kind of thing, perhaps.
Yeah.
Well, thank you both again. Thank you, everyone in the chat. Thanks for coming, stopping by. I need some outro music, but I'll see you all next time.